We have these axes. On the horizontal axis is our quantity, and on this vertical axis is our price. And this curve is the demand curve I just drawn. We are going to be calculating the price elasticity of demand on this curve going from point A to point B. And by that, I will explain to you how the price elasticity of demand can be calculated and what it actually means. So what it basically means is the percentage change in quantity over the percentage change in price between the 2 points. So we can calculate the price elasticity of a certain curve by taking these intervals between points and measuring the elasticity in this exact way as I just said, between points. Although there are also curves that fulfill the property that they have elasticity the same at all points, that is very rare and impossible in reality. I'm not saying it's impossible in reality, but probably it never happened. It's just not the way that there's certain cases in which you have the same elasticity on all the entire curve. It's just not real. You see, actually, you will see the elasticity is very different as we go throughout the curve if we choose different points. But I chose these two because when we move along the curve, we have different prices and different quantities at each point. At this point, we have price 10 and quantity 3. At point B, we have price A and quantity 5. And so, maybe this is a good moment to reveal the formula to calculate price elasticity of demand. So, it is usually denoted as ED, like this, and it's calculated as the change in quantity in percent. Okay, so we have to do it in percent over. Or you can say like the percent there is not really required, and I will show why it does not really matter. And then the change in price, and in percent is because it's proportional to the original initial value, and you will see how that works in a moment. So, and the percent is more like an intuitive tool for people who would otherwise be a little lost or would be discouraged for truly understanding it, or maybe it's like a help, intuitive help, because otherwise it would be maybe harder to grasp the idea or adapt the usage of it. So I just revealed the formula, and what does it say? Well, the percentage change in Q is basically the change between these two quantities going from our point A to B. And just to make it clear once again, we are calculating the price elasticity of demand on this curve between these 2 points. Okay, so we usually calculate it between 2 concrete points. It's for example, in this case, it's from A to B. I chose these points arbitrarily. You can choose either whatever other 2 points. Okay, but yeah, we go from the left to the right, and we choose to go from A to B. And so the difference between these 2 points, as far as quantity, let me just fill it in right here, or maybe I'll write it here. The change in quantity is 3 to 5, it's 2. Okay, so the change in quantity is 2. But in order to make it the percentage change, we will put it over the initial value so that it's 3. Okay, the initial value of quantity is 3. So we go to 3 to 5, so the change is 2. But the initial value is 3, so we do 2 over 3 is the percentage. And the percentage you do by taking the ratio and multiplying by 100. Because percentage, all it means is times 1 over 100. So the 100 and the 1 over 100 cancels out. Doesn't even, is not required. And actually in the end, you have times 100% here, times 100% here, and it cancels out. So I'm not gonna even write it there. And so, or I might, okay, so maybe let's do it. Just for the beginning, and then we will show why it's not even required. Now, with the price is the same thing. It goes from A to B, so it goes from 10 to 8. So the price change is minus 2. But again, we do it over the initial price, which is 10. And then we can again do times 100%. So, what we will get is the ratios of the change over the initial value, which is kind of misleading or maybe a little not intuitive and also quite hard to grasp. So definitely this will take not just this exact one example to get the hang of. It will require more effort and more repetition. And even after the repetition, it might happen, you will still be confused what you're really doing. And maybe it will take a very long time till you expand your understanding scope to be wide enough in order to be able to say, well, I definitely understand this 100% because this is a concept you can observe the curves and how the price elasticity impacts them, or how their shape has an impact on the price elasticity, and the way you calculate the price elasticity has impact on all the other things, how these all attributes to the entire idea have an impact to each other forever. It's very complex, okay, in a way, if you dig deep into it. And so we get the, as I said, ratio of the change in the quantity over the initial value of quantity, which is 2 over 3, and then we have change in price over the initial price, which was 10. And so we get 2 over 3 times 100 over all of that, over minus 2 over 10 times 100. And now we can basically just say these two cancel out anyway, you know? So it's not required. And then if we divide two fractions, we just switch the next one. So a division by a fraction is multiplication by the reciprocal. So it's 2/3 times 10 over minus 2. And this is 2/3 times 5 over minus 1. And it is 10 over minus 3. Okay, we cannot rewrite this as a different thing. I will leave it at here. It's close to, I don't know, it's something around minus 3.3 forever, which, you know, is not really rigorous. So we can stay with this, and we know this is bigger than 1. If we even put it into the value, it's actually smaller than minus 1. And if we put it into absolute value, it's bigger than 1, which is a very important property we will find in a little moment. So what it's told us basically is that the percent change in quantity was bigger than the percent change in price if we ignore the fact that there was a minus. Because with elasticity of demand, it will be minus, but we don't really care about the minus, and we get rid of the minus. We kind of ignore it out. Because we care about the elasticity, but we don't care that it's a minus really. You know, the demand curve goes down, the price goes down, and the quantity goes up, following the law of demand. So there's not much to really keep in mind, and why to keep the minus, you know. So that's the thing. Now, why is it important that, of course, this is mathematically rigorous, you know, the change was indeed minus 2, it was not 2. So therefore we got the minus all the way to the end. But yeah, you can either ignore it or keep that in mind. So we calculated the price elasticity of demand from A to B. Now we should maybe move to the theoretical part a little bit. So now it's really important to understand, and this video is more about the calculation, how to get it, than to really dig deep into all the philosophy behind it. But the thing is, if price elasticity, especially the absolute value, which means whatever number you take, you will get the positive variant of. A minus number, you will get the same magnitude, but it will be positive. Positive number, again, you will get positive through an absolute value. If we get the absolute value of d to be bigger than 1, which this case is exactly, this is bigger than 1, this is, as I said, approximately 3.3. Then we call this an elastic thing, elastic good. If this was a product, a good, okay, an elastic good. And if ED absolute value, and it's just to ignore the rid of this minus I spoke about here, is smaller than 1, then it is inelastic. The only difference between these two cases is that when ED is bigger than 1, it just means that the ratio between these two fractions tells us that the second one is smaller than the first one. And if it's smaller than 1, that means that the second one is bigger than the first one. Okay? So that's all it says. That the percentage price in quantity is smaller than the percentage change in price. then we have inelastic good. Then it's an inelastic good. But it's elastic when the percentage change in quantity is bigger than the percentage change in price. Okay? Why? Usually inelastic goods are those that do not react that much to the change, and the price is more like stable. And elastic, they're quite willing to change in price. Okay? So it's all about the reaction to changing quantity, price and quantity kind of relationship. So that's the idea of price elasticity of demand, and the same goes for supply, price elasticity of supply. Because with price elasticity of supply, again, the two things that you're playing with is quantity and price, nothing else. Okay, but you just work with the supply curve. That's the only different thing. Okay, so that's important. Now, if I arbitrarily chose some different points and they had different values, and whatever this was, the ED would end up, the absolute value of the ED would end up to be, for example, 0.3. Now this would be, and this does not apply for this because we calculated for this one and we saw it was bigger than 1. Then then ED would be smaller than 1, and the other variant would be fulfilled. It would mean it's inelastic. Okay, just to show how this might have also ended up if we chose different points. If we put it in different values, and this formula I revealed here gave us a value between 0 and 1. Okay, of course you can get a result that is 0. That's in the case when there's 0 change in quantity, for example. 0 change in quantity and some change in price. You can get such a result as well. But there's more deep insight into that, and I think this is more than enough for the single video, for the beginning video, I would say. This one shall help you understand how to calculate it. So just to repeat it once again in the end, you calculate the price elasticity of demand very simply. Is the fraction, is the ratio of two ratios. So the delta Q percentage, that means the percentage change in quantity is calculated as change in quantity over that's basically, if we say, I don't know, quantity 1 and quantity 2, that quantity 2 is the new quantity and quantity 1 is the initial one, well, it's the quantity 2 minus the quantity 1 over the quantity 1. Okay? And then the percentage change in price is P2 minus P1, where P2 is the final price at the second point, P1 is the price at the first point over the initial price. Okay? And one more thing that we should maybe mention, and you put these into ratio, and you get this normal number. And it's a ratio of two rational fractions, and so you get a rational fraction as a result also. So, and this will be 3 over 10 also. Rewritable as 3 over 10, you might say that. But that's not really important. But one more thing before we wrap it up is, there's another way we can calculate this thing. And instead of doing the delta Q, the percentage change in quantity being change in quantity over the initial, we would do change in quantity, which was the Q2 minus Q1, but we would do over the midpoint quantity, over the average between the two quantities. So it would be over 4 in this case. And the change in price, percentage change in price would again be the change in price, the actual change, minus 2, but it will be again over the midpoint, so over the 9. And this, what this basically does, and you will see that if you try it out yourself, try to calculate it by inputting instead of, and it will give you a different value in the end actually, but the value it will give you will be the same if you go from A to B and if you go from B to A. Unlike what we did in the beginning, the official, the most mainstream formula for it basically gives you something that it will give you a different result from A to B, and from B to A it will be a very different result. But if you calculate it over the midpoint, well, you will find out and you will figure out actually, in both cases, the numbers that you're using are going to be same, Okay. So at the end you will end up for the same result going from A to B and from B to A. But this is just a small review, and I'll maybe continue with this thing in another one.